Your ultimate goal when you're working with a word problem is often translating something into an equation, or at least this is one of your main goals. And the big difference between translating into an expression versus translating into an equation is if you're translating an entire sentence. If you say twice the height, this would be an expression. It's not saying anything about the number. It's just saying take the number and multiply it by 2. It doesn't say that it is something else. Once you say that two numbers are equal, then that's when you actually have an equation. So, and when you're talking about it being written out in English, that's when you have a full sentence. So the height of the duct is equal to twice the width. You can see is equal to. There's that is equal to, that's going to be an equal sign. That's how we know that we're going to be dealing with a full equation here. The height of the duct, this is one number, you might call it h, and twice the width, well, twice is going to be 2 times, and the width we'll call that w. So the height of the duct is twice the width. I would translate that as h equals 2w. We call this a direct translation because I'm taking this and not changing the order of anything. I'm literally just replacing the height of the duct with h is equal to with equals, twice with 2 times, and the width with w. Alright, the size of the drill for a tap, that's one number, is equal to, that's an equal sign. The tap diameter, that's another number, minus the depth. So the size of the drill, let's call this, I don't know, S for size, I don't know, equals the tap diameter, we'll call that D, minus the depth, which I'll call lowercase d. This is another trick that sometimes we do when we want to use the same letter multiple times. You might use a capital D for diameter and a lowercase d for the depth. This is why if you've tried putting things into the computer and it counted you wrong, and you're like, well, I have a lowercase letter here, why doesn't it count that as the uppercase? It's because in math we're often so hard pressed to use the variables. We keep wanting to use d for multiple different things, so what we do is we say that there's a distinction between lowercase and uppercase, and if you want more than that, you can use subscripts, d1, d2, d3, d4, and so on. That would be another way that you could make more use of d's, or if you wanted to use more s's or something like that. Alright, a sheet metal worker is measuring a duct cover, finds that the width is 8.5 inches less than the height. So this is a it is a full statement, but it doesn't say is or is equal to or anything like that. However, this if you kind of break this down, I don't really care that it's a sheet metal worker measuring the cup. It finds that, okay. Oh no, I guess never mind. It does say the width is 8.5 less than the height. This is height minus 8.5. You can see I was just kind of crossing out the extra words in here until I got down to the actual equation that was, the only part that was actually saying things about the numbers is that the width is 8.5 inches less than the height. And so that's the part I focused in on. Alright, 1/4 of a job takes 3.5 days. Alright, so this is the one I was expecting when I said that it doesn't say is. This one, it says takes. And, well, 1/4 of a job, this is really referring to the length at the time of 1/4 of a job is 3.5 days. So what I did here is I just kind of rephrased this a little bit, so that I actually have some, so it's a little more clear about what the variables are, what the numbers are that we're talking about, the time of 1/4 of the job. So that is the length of the job, or the time the job takes, times 1/4. This would be 1/4 of the time of the job. I know that it's the time of the job, not the dollar value of the job, because, well, you get that just through context. It says it takes 3.5 days. Clearly we're talking about a time measurement here. With English, you can be ambiguous like this, and it's left to the reader to interpret that ambiguity. This is one of the strengths and one of the weaknesses of natural language. It's, oftentimes you can do something like this, leave it ambiguous, and it's left to the reader to figure out what is meant. And that's why I think oftentimes word problems are so much more difficult for people, because it's not the math that's any more difficult, it's the English that's more difficult there. So we'd get 1/4 t equals 3.5. I'm not solving any of these because I'm just trying to translate them. I'm just focusing on that part right now. This is another instance where we don't say is or anything like that, but you can see the verb here, weighs. This is talking about the weight of 1/2 the coil. The weight of 1/2 of a coil is 16 2/3 pounds. So again, I rephrase this so that I can get the word is in there, and also so that I'm describing numbers. Instead of just saying 1/2 the coil weighs this amount, I'm talking about the weight of 1/2 the coil, because this means the weight of 1/2 the coil, this is going to be 1/2 the weight. Is, it gives me an equal sign, and 16 2/3, well, we already get that from there.